Suppose someone tells me that the mean GPA for all currently enrolled DCC students is 2.74. I'm not sure I believe what the person told me, so I decide to go out and collect a random sample of 85 currently enrolled DCC students and write down their GPAs. My sample of students has an average, there's a typo there, has an average mean GPA of 2.86. So part A asks us to describe the population. So the larger group of observational units that we're trying to make conclusions about here is all currently enrolled DCC students. The person that I talked to made a claim about all currently enrolled DCC students. Part B asks us to describe the sample. So I couldn't talk to all currently enrolled DCC students and find out all their GPAs. So instead it says I talked to a random sample of 85 currently enrolled DCC students. So just a subset of the population. Part C asks us to describe the parameter. Remember, parameter is a number related to the entire population. So the parameter here is actually an unknown. This person told me they think the parameter is 2.74, but I'm not sure I believe that. I'm not sure that is accurate. So a parameter is actually unknown. Just like always, we generally do not know the parameter because we can't possibly talk to every element of the population. The parameter here is the mean GPA of all DCC students. Notice to get that, we would have to talk to every single DCC student and write down their GPA and then take that great big list of numbers and find the average, the mean of all of those GPAs. There's no way we can do that. There's way too many DCC students to do that. So whatever that number is, it's an average, it's a mean, and the symbol we use for the mean of an entire population is mu. Mu, that's the one that looks like a little U with a longer tail on the left side. It's pronounced mu. So mu is the mean GPA of the entire population of currently enrolled DCC students. We don't know what it is. Whatever it is, it's some number that we're trying to figure out. Part D asks us to identify the statistic. So the statistic is the number from our sample. It's actually observed, and it says here when we took our sample of 85 currently enrolled DCC students, our sample gave us a mean GPA of 2.86. The symbol that we use for the mean of the sample is X bar. So the mean GPA from our sample of 85 students is 2.86. That's a known value. We actually observed it from our sample. We went out and we talked to 85 currently enrolled DCC students. We wrote down the GPA for every single one of those 85 students. We'd have a list of 85 numbers, and then we would find the average. We'd find the mean of those 85 numbers, and that mean turned out to be 2.86. Part E asks us to describe the variable. So every time you walk up to one of these 85 students, you would pull out your clipboard and you would write down that student's GPA. So that's the variable. The thing you write down about that observational unit is the variable. The variable here is the GPA of each student. Part F asks if the variable is categorical or quantitative. The variable in this case is quantitative. You would be writing down a number on your clipboard. You'd be writing down a GPA, which is a number. All right, so here is the chance model I created from a simulator. And over here on the right, you can kind of see a few elements of what I entered in there. So first of all, we are assuming that the population mean is 2.74. Remember, we're doing that because we're trying to understand if my friend is right. My friend said the population mean, the mu, is 2.74, and we're trying to understand if that seems correct or not. So in the simulator, I said, all right, well, we took a sample of size 85, and I asked the computer to do 100 different simulations there of size 85, where the population mean is 2.74, and show me what the sample statistics should look like. All right, so again, I kind of wrote the same sort of thing I wrote back in example 1. A chance model is called a distribution of sample statistics. It's showing us the expected, usual statistics we'd get if the parameter were equal to this value, in our case 2.74. The statistics shown are close to the value of the parameter, so our statistics would be close to 2.74. So the population mean, if the average GPA was 2.74 at DCC, then when you go out and collect a sample, you should expect to get sample means close to 2.74. We create this chance model so we can see the amount of spread and variation that we should expect from sample statistics. Every one of you who created a simulation chance model would get a very similar chance model to this one. All of us would have a chance model that had a mean of approximately 2.74 because that is the population parameter. So Part J, it says if the average mean GPA of all DCC students is truly equal to 2.74, then what types of sample statistics would be normal, usual, and expected when we sample 85 students? So that's what the chance model is showing us. It looks like there's a lot of samples that are around values of sample mean 2.7, 2.71, 2.72, 2.73, 2.74, 2.75, 2.76, maybe up to 2.77. Getting up here into 2.79 and higher, there aren't sample statistics like that. Getting down here to below 2.7, there don't seem to be sample statistics like that. So these, the ones where we have lots of sample statistics showing up like that, these seem to be the normal, usual, expected. So I would say I expect my sample statistic X bar to show up between something like 2.7 up to 2.77. Okay, so I wrote, the chance model shows us that we expect the sample statistic X bar to be somewhere between 2.7 and 2.77. Again, that's kind of just a rough estimate. Lower than 2.7 or higher than 2.77 would be unusual if the mean GPA of students is actually 2.74. So overall, what do we now conclude? So now I actually look back at the X bar we saw in our sample statistic. It says here, our sample statistic was 2.86. When we collected our sample of 85 students, we got a mean GPA of 2.86. So 2.86 is in our realm of unusual. That means our X bar would be way up here, off the chart. It's not an X bar that shows up in this chance model as something that would happen if the mean GPA of all students was 2.74. So what I concluded was, our research question was, is the average mean GPA of all DCC students equal to 2.74? We had a sample statistic of X bar equals 2.86, and that was an unusual, unexpected outcome according to our chance model. So we conclude that we have strong evidence that the average mean GPA of all DCC students is not actually 2.74. Remember, if the mean GPA of all DCC students were actually 2.74, then we would have seen a sample mean somewhere between 2.70 and 2.77. That's what the chance model showed us. But what we actually observed in reality was a sample mean of 2.86. So that does not match up with what the chance model showed us. So we conclude that we have strong evidence the mean GPA of all DCC students is not actually 2.74.